Hi there, this is the last section or example that I was going to do on hypothesis testing about a population mean, and this one talks about a small sample. Um, Here we're looking at the mean exit velocity of all home runs hit in Major League Baseball is 103.53 miles per hour. Over his career, Mike Trout of the Los Angeles Angels has hit 240 home runs. The following data represents the exit velocity of a random sample of 10 home runs hit by Trout. And we want to know, does the evidence suggest that Trout's home run exit velocity differs from the league? And we're going to use an alpha equals 0.05 level of significance. So you can see that this time we have a data set. So if you look here, we have n equals 10, which is definitely below our threshold of 5, our threshold of 30, which means that we have a small sample. So we can't assume that this is normal. So remember, we had some methods that we could use that we learned in section 9.2 to figure out whether or not we could assume the small sample was normal. And so the two things we wanted to do, and I'm going to use, if you remember right, there were two methods. I'm going to use method 1. And so method 1, that was the preferred method, was that we were going to do, first of all, a normal probability plot. And sometimes, if you remember, when we went into StatCrunch, that was called a QQ plot. And then what we're looking for there is the linear relationship. So we're looking for the correlation coefficient. We want a correlation coefficient which was our R, and we want that to be greater than R greater than an R critical. That R critical is based on our sample size. So we will find, or I'll tell you what the critical value for the correlation coefficient is for a sample size of 10. And we can find that either in that table at the back of the book, or it'll be given to you in a problem. And then the second thing that we'll look at is a box plot, and there we're looking for no outliers. So let's start with the normal probability plot. If I look up our critical correlation coefficient here, my critical R value for a sample size of 10 for n equals 10 is 0.918. So we are looking for a correlation coefficient in StatCrunch with this data that's higher than 0.918. So let's go over to StatCrunch real quick, and we're going to look first at the normal probability plot and then at the box plot. So if I pop over there, what you'll notice is I already put in the velocity data. I'm going to use this information. If you want to input it and do it along with me, go ahead and pause and you can input the data yourself. We are going to go to graph. We're going to go down to QQ plot, and it'll pop up with QQ plot. We're going to select the columns, and here we're going to pick the velocity. We want the correlation statistic, and we want the normal quantiles on the y-axis. So we're going to have it compute, and we end up with this plot right here. You notice right up at the top, it has a correlation of 0.979. That is our correlation coefficient. So that's our R value. So let's go back over to the other one. So we had 0.979 was our R value, and that is greater than 0.918. So this shows that we're good on this condition. And then the second part was that we wanted to look at the box plot and ensure that we didn't have any outliers. So again, we go to graph, we go down to box plot. I'm going to again choose the velocity, and I really just need to I just need to hit compute, And what we don't see there is any outliers. So since there's no outliers, we are good to go here. So let's go back over to the other thing. So there's no outliers. So we're good here. So that means that we can go ahead and use a t-test here, and we can assume that this is normal, okay? So we're going to say this is normal, a normal distribution. So let's go ahead and do our null and alternative hypothesis. So we're going to start with that. Our null hypothesis, remember, is going to be the status quo. It's what we know happens. So here, the mean exit velocity of all home runs hit in a Major League Baseball is this 103.53 miles per hour. So we're going to assume that Trout's home run velocity is the same to start with. So we're going to come up with the mean is equal to 103.53. Our alternative hypothesis, if we look, we want to know whether or not does the evidence suggest that Trout's home run velocity differs from the league. So since I want to know if it differs, that means it's not equal. I want to know if it's greater than or less than. So I'm going to use the not equals on my alternative hypothesis, 103.53. And then I'm going to note that my alpha, my level of significance in the problem, is 0.05, right? So note, since I'm at not equals, here I'm doing a two-tail test. Alrighty. So let's go over to StatCrunch. We're going to find our mean and our sample standard deviation, and we'll go from there. So if I go back over to StatCrunch, I can use I can use summary stats. And what I really want to know is, well, this one looks interesting. Columns, and I'm going to look at the velocity. What I really want is just the mean and the standard deviation. I don't need all this other stuff. Alrighty, and I can tell it to compute. And so what I see is that the mean is 106.4, and the standard deviation is 2.7289 with a sample size of 10. So I'm going to go back over to where we were at and write down some of this information. So I have n equals 10. That means my degrees of freedom for my t-test is going to be n minus 1, which is equal to 9. I also know that my mean, my sample mean, is 106.4. And my sample standard deviation was 2.7289. Right, so from here, I can calculate my t-value, my student's t-value, which remember is the sample mean minus our population mean, or assumed population mean here, all over our sample standard deviation over the square root of n. Make sure you're doing this part all together down here on the bottom. So we're going to have 103.53. No, sorry, I'm going backwards. We're going to have 106.4 minus 103.53 all over 2.7289 divided by the square root of 10. So if we pop that into our calculator, and I'm going to double check this real quick, 0.4 minus 103.53. On the top, I get 2.87, and on the bottom, I have 2.7289 divided by the square root of 10, which is going to be 0.86295. So overall, our t is going to be equal to that times 2.8 is going to be equal to 3.3258. So this is my t. Now remember, because this is a two-tail test, right? We had the two-tail test. Then I'm looking and hoping that I need to have each tail contain less than alpha divided by 2. So if I look here at t equals 3.3258, this is my t value, and look to the right of that, and I have my t equals negative 3.3258. I want both of these tails to contain less than 5% together. So I want one of them to contain less than 4%, or 2.5%. So 0.025. So remember, when we calculate this, what we can do is we can find the probability, or 2 times the probability that t is greater than or equal to 3.3258. Okay. So if I go back over to StatCrunch, let's find that probability. And we go back over to StatCrunch. We're going to close this. We're going to go to calculators. We're going to look at the t calculator. Yep. Our degrees of freedom here were 9, if you remember right, because that was n minus 1. We're looking for greater than, and our t value was 3.3258. And if I say compute, you see the really, really small area there, and I have 0.004429, it goes on, right? So if I pop back over here, I'm looking at, and this is my p-value, okay, is 2 times the 0.0044, which is going to be equal to 0.0088, which is certainly less than 0.05. Erase that line right in the middle. There we go. We'll make it tinier. All right. If I wanted to go to StatCrunch and do this directly in StatCrunch, right, my StatCrunch method, then I can come over and I'm going to close this. I still have all my data here. I'm going to do stat. I'm going to this time do, I'm going to get rid of the calculators. I want to do tstat. I want to do one sample. I see what it's doing. I want to do with data this time. Okay, so my data is going to ask me what column it's in, and here it's in the velocity column. I'm going to go down to my hypothesis, and I want to test for a mean, a population mean of 103.53. I want not equal to that. So that's what we have here. That was what my null and alternative hypothesis were. So I can go ahead and hit compute, and what you see here is my t statistic matches the one that we calculated, 3.3258, and the p-value is 0.0089. So if I pop back over here, I get a p-value equal to 0.0089. You'll notice that the two p-values are very, very close. This is just rounding. So this again is less than 0.05, which is my alpha. So in both cases here, I'm going to reject my null, and here I'm going to reject my null. These are the same results, so it's just 2 ways to do it. All right. So basically you have 2 ways that you can show this, and this is with a small sample. If I want to go ahead and write this up, I'm going to fly to the very end here real quick. Oh, maybe I won't. That was a long one. Okay, let's add a page. Oops. So we're going to add a page. And if I wanted to write up the results of this, what I would say is there is evidence to reject the null hypothesis. And support the alternative. Well, let's not say that. To support that Trout's home run exit speed or velocity, I guess, is different from 103.53 miles per hour. Right? So that would be what we would say since we have evidence to reject the null hypothesis and to support the alternative. Right? So if you have any questions, let me know. This is the last example that I was going to do. And I hope it's helpful. See you soon.